Hello students, my name is Vijayan and I welcome you again for today's program, which is on the second part of simultaneous equations. At the end of today's program, you should be able to solve simultaneous equations using the elimination method and solve word problems involving simultaneous equations. I am sure that some of you may have forgotten what simultaneous equations are. Let us make a brief recap. At the level of grade 9, simultaneous equations consist of a pair of linear equations which is satisfied by the same values of the unknowns. Here is an example. The solution to the above equations is x is equal to 1 and y is equal to 6. Remember that these values satisfy the two equations. In the first part of the chapter, you learned about two methods to solve simultaneous equations, namely the graphical method and the substitution method. Today, you will learn about another method which is known as the elimination method. So let us see what this elimination method is all about. The elimination method consists of eliminating one unknown from the two equations using two rules. The first rule is as follows. Suppose we want to eliminate y. Then, if the coefficients of y in both equations are the same, with the same signs, we use the SSS rule, that is, the same signs subtract rule. To clarify further, let us consider an example. Here we have to solve the simultaneous equations 5x plus 2y is equal to 19 and 3x plus 2y is equal to 13. As we did in the previous method, the first step would be to label the equations. Now students, look at the two equations carefully. You will notice that the coefficients of y are the same in the two equations and have the same signs. So in this case, we will use the SSS rule. That is, we will perform subtraction to eliminate the y terms. This is done as follows. We write the two equations one underneath the other and we subtract. By doing so, the terms in y are eliminated and we are left with 5x minus 3x on the left hand side is equal to 19 minus 13 on the right hand side. If we solve this equation, which now involves x only, we get x is equal to 3. With this value of x, we can find the value of y using any one of the two equations. For instance, from equation 2, we obtain y is equal to 2. Remember students, it is good that you check whether these values satisfy both equations. Let us now have a look at the second rule for the elimination method. Again, if we have to eliminate y, then if the coefficients of y in both equations are the same, but with different or unlike signs, we use the USA rule, that is, the unlike signs add rule. Let us consider an example. Here we have to solve the simultaneous equations 3x plus 2y is equal to 12 and x minus 2y is equal to 12. Again, we start by labeling the two equations. Have a look at the coefficients of y in this case, students. You will notice that the coefficients of y are the same in the two equations, but now they have unlike signs. In this case, we will use the USA rule. That is, we are going to perform addition. When we add the two equations, the terms in y are eliminated. We are left with an equation in x. The solution to this equation is x is equal to 6. With this value of x, we find the value of y by replacing in equation 1, for example. We get y is equal to -3. We can again check whether the answers are correct by verifying whether they satisfy both equations. The last example is somewhat different from the first two examples. Let us have a look. Here we have to solve the simultaneous equations 3x plus 2y is equal to 5 and 4x plus y is equal to 10. After labeling the two equations as usual, you will note that here the coefficients of y are not the same in the two equations. So we will not be able to use the rules here. In that case, what we will do, students, is that we will make the coefficients of y become the same. This will be done as follows. We keep equation 1 as it is, but for equation 2, we are going to multiply it by 2. And it gives 8x plus 2y is equal to 20. Remember that each term of the equation has to be multiplied by 2. Now, students, with these two equations, one underneath each other, observe the coefficients of y. You will see that here, the coefficients of y are the same in the two equations, and also they have the same signs. So according to you, students, are we going to use the SSS rule or is it the USA rule that we will use? Look at the coefficients and the signs of the terms in y. Yes, I am sure you have correctly guessed that here we have to perform subtraction to eliminate the terms in y. By doing so, we get an equation in x, and we find the value of x as 3. With this value of x, by replacing it in any one of the two equations, we get the value of y as -2. Again, it is advisable that you check your answers whether they satisfy both equations. Now, students, in all the examples that we have considered so far, you have seen that we have eliminated the y terms. What about the x terms? Can we do elimination with the x terms? Yes, students, we can do this. In fact, if we want to eliminate x, the same rules will be applicable. That is, either we are going to add the two equations or we are going to subtract one equation from the other, provided that we have considered the coefficient and the sign of the x terms. Look at this first example. I am sure you can identify which one of the rule has to be used to cancel out the x terms. Look at the coefficients and look at the signs. Consider this second example, students. Here, in the first equation, we have 5x, and in the second equation, we have -5x. I am sure you will know which rule we have to use here to cancel out these x terms. Here are some exercises for you to practice using the elimination method. Now that you know how to solve simultaneous equations using different methods, we move on to the last part of the chapter, which is on word problems involving simultaneous equations. Let us consider an example where you will see what this is all about. Kevin buys 5 kilograms of potatoes and 2 kilograms of tomatoes at the local market for a total of 220 rupees. Selvina buys 6 kilograms of potatoes and 5 kilograms of tomatoes at the same market for a total of 420 rupees. Given that the prices of vegetables are fixed at the local market, find the price of 1 kilogram of potato and 1 kilogram of tomato. Now, students, when you look at such a problem, you will see that we do not find any equations at all. So let us see how this example is tackled. We start by denoting the price of 1 kilogram of potato by X rupees, and also the price of 1 kilogram of tomato as Y rupees. We do so because these are the unknowns in the question that we have to look for. Now, we were told that Kevin bought 5 kilograms of potatoes and 2 kilograms of tomatoes for a total of 220 rupees. Now, students, if 1 kilogram of potato costs X rupees, it means that 5 kilograms of potatoes will cost 5X rupees. In the same way, 2 kilograms of tomatoes will cost 2Y rupees. Now, these two make a total of 220 rupees. It means that when we add 5x and 2y, we should be getting 220 rupees. This is our first equation. In the same way, we were told that Selvina bought 6 kilograms of potatoes and 5 kilograms of tomatoes for a total cost of 420 rupees. With this information, we have the following equation. 6x plus 5y is equal to 420 rupees. Now we have the two equations in the problem, students. So we are going to solve these two equations simultaneously. We start by writing the two equations one underneath each other. Here you will notice that the coefficients are not the same in the two equations for x. What we will do is that we will modify these two equations and multiply them by numbers so that the coefficient of x become the same. Here, we wish to make the coefficient of x become 30. 30 is the LCM of 5 and 6. This is why we multiply the first equation by 6 and the second equation by 5. We get two new equations where now you find that the coefficient of x are the same and they have the same signs. So for same signs, we perform subtraction. By doing so, we get the value of y, which is 60. With this value of y, we find the value of x using any one of the two equations. We will obtain x is equal to 20. So the solution for this question, students, is given as follows. The cost of 1 kilogram of potato is 20 rupees and 1 kilogram of tomato costs 60 rupees. Let us now consider the last example based on word problems. Saif is 25 years younger than his father. In 3 years' time, the sum of their ages will be 75. Find the present age of Saif and that of his father. Now, if you consider this question, students, you will see that we are looking for the present age of Saif and that of his father. This is where we will start with our solution. We will denote these two information by x and y respectively. Now, we are told that Saif is 25 years younger than his father. It means that when I take the age of Saif's father, I subtract the age of Saif, I should get 25. This is one possible equation that we might write down with this statement. Also, we were told that in 3 years' time, the sum of their ages will be 75. Now, in 3 years' time, Saif's age would have increased by 3. This is the same case for Saif's father, whose age will also increase by 3. The sum will make 75. It means that when we add these two ages, we will get 75. Now, when we simplify this statement, we get x plus y is equal to 69. So now that we have the two equations, we are going to solve them simultaneously. Again, here, student, you will note something different. The orders of the variables or the unknowns in the question, in the two equations, are not the same. In the first equation, y is in the first position. However, in the second equation, we find x first. So we are going to rearrange them so that they are the same order. Now we can proceed with the elimination method. We are going to add the two equations to eliminate the x terms. By doing so, we get y is equal to 47. That is, the age of Saif's father is 47. With this information, we can find the age of Saif and we obtain x is equal to 22. So the solution to this question, students, is at present, Saif is 22 years old and his father is 47 years old. Here are some questions for you to practice. To summarize, in today's program, you have learned how to solve simultaneous equations using the elimination method. You have learned that there are two rules using this elimination method, namely the SSS rule and the USA rule. You have also learned about how to solve word problems involving simultaneous equations. Briefly, the steps are as follows. We start by denoting the unknowns that we are looking for by letters. We formulate two simultaneous equations based on the information given in the question. We verify whether the order of the unknowns are the same in the two equations, and we solve using one specific method. Here are some links that you might find useful to consolidate whatever you have learned today. So students, this is the end of today's program. I hope that whatever we have done will help you in your studies. Until we meet again, it's goodbye from me.